homework time. Time to get your crayons and your pencils. All right, so let's go ahead and start with always do, jotting your name down at the top. You write your name unless your name also happens to be Mr. McGrath. Then you can put the same thing I'm putting there. And then for the date, you write the actual date, where and when you are. I will write today. Great. Let's read. Now, before we even read this, I can tell you, you need to have a little bit of prior knowledge or have somebody explain to you what this means. So when you're in college, there's two parts of the college year called semesters. There's a fall semester, beginning of the year, say, and the spring semester, the second half of the year. And so in a semester, you might have a project to do, as the guy in this problem does. So the semester is about 15 weeks. And so you think that's about 4 months or so, 3 to 4 months. So let's look at the question with that prior knowledge in the back of our heads. So it says Zachary's final project for a college course took a semester to write and had 95,234 words. Zachary wrote 35,295 words the first month and 19,240 words the second month. Okay, so let's not make this harder than it needs to be. Let's recognize, let's draw a little tape diagram here, that we are dividing this time period into 3 simple sections, okay? We don't have to get too complicated with how many weeks and months. We have the whole semester, and then we have the first month, and the second month, and then the rest of it. Okay, so we're taking that whole time period and dividing it into 3 sections. Okay, so what we can do is round each value to the nearest 10,000 to estimate how many words Zachary wrote during the remaining part of the semester. Okay, so let's think about this. So go ahead and take that 95,234, and we don't need to do number lines anymore. We know how to round. We learned that. So we'll kind of walk through this one, though, mentally. So we have 9 10,000s. We're rounding to 10,000s place. 10,000 more would be 10 10,000s. So we're talking about 90,000, 100,000. Midpoint would be 95,000. And this, you see, is slightly above that midpoint. So we would be rounding up to 100,000. And that's one of the harder ones to do. So if you are at all confused, go ahead and take a moment and draw out a vertical number line on that. So now the first section of time, the first month, we have 35,295 words. And remember, again, we're rounding to nearest 10,000. So we'd say 3 10,000s, 4 10,000s. Midpoint would be, you got it, 35,000. And this, you see, is right above that. So we'd round up on this one as well to, that's right, 40,000. Or 4 10,000s, I could say, as I did before. And now the next number should be comparatively easy to round. We have, remember, we're going to 10,000, so we have 1 10,000. Next would be 2 10,000, so we're talking about 10,000 and 20,000. Midpoint is 15,000. 19,000 is above that, right? So we'd round up to 20,000. So this is going to give us an estimate when we round all the numbers involved. Now this is what we're trying to find here, the remaining part of the semester. Let's call it R for remaining part. To find this R, we need to know what these are together, right? In order to subtract them from here. And now you could do it different ways. You could take the 100,000, subtract the first part, then subtract the second part, and that would give you the third part. Or we could combine these two first and then subtract them, okay? Which I think you'll see is going to be easier when we get to doing the actual numbers. There's a good chance you can look at 40,000, 20,000, and add those in your head without really having to, scritch the pencil around, right? 4 10,000s and 2 10,000s make 6 10,000s, aka 60,000. And I suspect there's even a chance that you can do the subtraction. I'll write it out, and write it out with me so you can see it. You probably do the subtraction in your head here, but let's take a look at it, make sure we're doing it right. We're doing 100,000 minus 60,000, which will give us that remaining part of the semester. And so we have 0, 0, 0, easy stuff. 0, drop that comma. And now here, there's two ways to do this. We could do the regrouping we've been doing, but since we're kind of at the end of the line, we could also see this as 10 minus 6, can't we? Because when we do the regrouping, that's what we'll be doing. Watch, I'll show you. You can look at this just as 10 minus 6 is 4. But look, here's the regrouping, right? We come over here, that's 0. And then we bring 10 over here, and we're doing 10 minus 6. There it is. So you can kind of save yourself a little scritchy scritch. So 40,000 is our estimate. Okay, so that's our estimate for the remaining part of the semester. Let's go take a look at Part B. We'll need some of this information to tag along after us. All right, now for 2B, like I said, we need the information from up above, so I copied it on here. So we want to find in Part B here the exact number of words written during the remaining part of the semester. We just did an estimate, so we won't take the time to draw another tape diagram. It's going to look the same, except that it would have the exact numbers instead of our rounded numbers. So we need, and now you see why we want to combine these two first. Otherwise you have to subtract twice with all that regrouping, and that's just, I don't know, more work. So let's do it the easier way, huh? All right, so we have 35,295 in the first part, 19,240 words in the second part, and we want to find that remaining third part. So we'll add these up. So we have 5 plus 0, 5, and 9 plus 4. Got it, 13. Regroup that 1, 1 and 2 and 2. 5. 5 and 9 make 14. Regroup the 1, drop that comma. 1 and 3 and 1 are 5. Okay, great. And so now we will take the total number of words and subtract parts 1 and 2 here, and that will give us the remainder. Okay, so we have 95,234 words, and in the first two parts of the semester, the first 2 months, he did 54,535, and we want to find the remaining part, so it'll be the difference between them. And we see right off we're going to have some regrouping to do, so let's do it. All right, we can't take 5 from 4, so we go over to the tens place, take one of those tens, leaving 2, bring it over as 10 ones with the 4 already there. It's 14 minus 5 is 9. We can't take 3 from 2, so we go to the hundreds place, leave 100 there, and bring over 10 tens with the 2 that are already there for 12 minus 3. You got it, 9 again. Okay, and we cannot take 5 from 1, so we go over here, leave 4 of those thousands, bring over 10 hundreds to the 100 still there. So now that gives us 11 minus 5 is 6. Oh, we catch a break. 4 minus 4, 0. Drop that comma. And then 9 minus 5 is 4. Okay, and that makes sense, doesn't it? And that's actually what question 3 is. Is our answer reasonable? And let's go do that then, part C. Okay, so you can see I cut and pasted over here into part C our estimate from part A, there it is, and then our actual from part B. And so our instructions are then to use your answer from A, the estimate, to explain why your answer in B, the exact calculation, is reasonable. Okay, so if we look at it, we see, okay, we're looking at our final answer here. And rounding to the nearest 10,000, which is what we did, it actually rounds exactly to our estimate. So that says this is a reasonable answer because we have 4 10,000s here, definitely below the midpoint of 45,000, right? Okay, so our answer is reasonable. Why? Let's start off with that. Our answer, or you might want to put my answer. I'm speaking for the both of us. Your teacher might wonder why you wrote R. Is reasonable and now why? Because it says explain why. Our exact number, our exact answer, we can say, rounded and what place do we round to? To the nearest 10,000. Now, how does it compare to our estimate? Well, it would actually be equal, right? So if we round off our exact answer, it would be equal to our estimate. It doesn't have to be, it just has to be in the neighborhood, right? But it actually is equal to it. So our answer is reasonable because our exact answer, rounded to the nearest 10,000, is equal to our estimate. We can be pretty well assured that we have a reasonable answer here. Even if we made a little calculation error, we know it's good. All right, so that's 1ABC. Let's bing, flip the page and look at number 2. All right, now number 2 is an excellent illustration of why we do all this estimating and rounding, because it helps you keep things straight and know that your answer is reasonable. Okay, so let's read number 2. During the first quarter of the year, 351,875 people downloaded an app for their smartphones. During the second quarter of the year, 101,949 fewer people downloaded the app than during the first quarter. Okay, how many downloads occurred during the 2 quarters of the year? So the 2 of them together. And so we'll do first is round each number to the nearest 100,000. That makes it easy to estimate how many downloads occurred during the first 2 quarters of the year. If we were to draw a tape diagram on this, it would be a little tricky, to be honest. So if we were to draw this out, see, this is different because what we're trying to find is the whole shebang, right? We're trying to find the first 2 quarters. So, let's call that Q. That's what we don't know. Now we do know the first quarter is what? 351,875. Now on this second quarter, we know it's 101,949 fewer. So if we were to draw that out, we'd say, oh, okay, well, this is the same as that, let's say, and we're going to need to, subtract out this part, all right? And that's the 101,949. If this whole part here is also 351 875. Okay, so I don't know if that tape diagram helps you. We weren't required to draw a tape diagram, but I think it does help you see that we're doing first quarter plus this minus that. And then we have to combine them both to get the 2 quarters, okay? So we'll start off with the rounding dough. That's easier. So let's find the second quarter first. We don't have a number for the second quarter. And we're rounding to the nearest 100,000. So 351,875. Does that pass the midpoint between 300 and 400,000? Yes, indeed it is. So that would be 400,000. And then we need to subtract out this part here, the difference, the number of fewer people, and that would round to what 100,000? Right, to 100,000. So you can see it's right close to it. And that's obviously what? Yes, 300,000. Now some of my zeros there look like trapezoids or something, sorry. All right, and now, but are we done? No, because we want to find for the first 2 quarters. That just gives us for this second quarter. All right, so what do we need? Yeah, we need to add the first quarter to it, which we already rounded to 400,000. We can write out a new one here, or we can just keep going here. Add in the 400,000, which is the rounded 351,875. And you see quite easy what we get for Q for the first 2 quarters. Our estimate is 700,000. Now, even before we get to the actual, that's our Q. That's the whole 2 quarters there. Now, although I suppose I should be more accurate, and this bracket should actually end here. All right. Now, because we're rounding to the nearest 100,000, our actual is probably not going to be too close to 700,000, right? You know that already, because in rounding 351,000, we're rounding it up like over 48,000 up to the next 100,000. That's a big difference, and then we're doing 2 operations with it. So the bigger the numbers and the larger the place you're rounding to, the larger the difference you're probably or likely to have, or more likely to have to your actual. But we'll see. Let's go on to 2B. All right, here in 2B, you see I pasted in the question from up above. You have it before you. So now we want to determine exactly how many downloads occurred during the first 2 quarters of the year. So now we have to deal with the real numbers. But see, that's why we took the time to understand it and draw that little tape diagram, as complex as it was, just so we can know what we're doing. So we know we can get the second quarter if we take the exact number, right, from the first quarter, 351,875, and we subtract the difference, how many fewer people, 101,949, and this will give us the number of people who downloaded it in the second quarter. So let's do some subtraction. Hey, all right, here we go. So we cannot take 9 from 5 without a little decomposition action. Go to tens place, leave 6 tens there, and bring 10 over to the ones place with the 5 already there. Now we can do 15 minus 9 is 6, good, and 2 minus 4. I'm sorry, 6 minus 4, I gave you the answer. Boy, yeah, it's 2, okay. All right, now we've seen this before. We cannot take 9 from 8 without regrouping. So we go to the thousands place, leave 0 there, bring over 10 hundreds with the 800s already here. So 1800s minus 900s leaves, yes, you know your doubles, 900s. Now here we have 0 thousands left. So we cannot take that 1. So let's go to the 10,000s place. I'll leave 4 of them there and bring over 10 thousands to the 0 thousands we had. Now we can do 10 minus 1 is 9. Drop that comma. And now 4 minus 0 is still 4, and 3 minus 1 is 2. Lovely. But remember, that only gives us the second quarter. When we do know the first quarter, we just have to put them together to get the 2 quarters. So this is just addition. No biggie. I will write this one separately, though, because using the actual numbers is not quite so simple. Is it now? All right, and so we're going to add to that 249,926. Great. Remember addition. Don't get your head stuck in subtraction. 5 plus 6 is 11. Regroup that 1, and you see we have a make 10 fact here. Say 8 and 2, or you could say 7 and 3. Make 10. Place the 0. Regroup the 1. And you do see a pattern here. 9 and 1 make 10. 8 more is 18. You group that 1, and there's another 9 and 1 make 10. 1 more is 11. Group that 1. Drop that comma. 1, 5, and 4. You can see 6 and 4 and 5 and 5 make 10 again. And now we have 1 plus 3 plus 2 is, yes, 6. So the actual number of downloads during the first 2 quarters of the year is 601,801 altogether. Okay, now you probably anticipate in part C we're going to compare our estimate with our actual and see if our answer is reasonable. Let's do it. All right, now to determine if the answer is reasonable, we compare our estimate with our actual results to see if, they make sense together. So I pasted in here, here's our estimate, and here are our calculations from the actual. And when we compare them, what do we see? See, so here's the subtraction. 300,000, 249 is just below the midpoint, so it doesn't round up to 300,000, but it's close to it. And then look how far off our estimate of 700,000 is from the actual of 600,000. But remember, I kind of warned you. I said we're doing a very far rounding in the hundred thousands place. So this kind of disparity, the difference between the estimate and the actual, is totally normal. Okay, and so our answer is reasonable because we were rounding to such a high place. Okay, so that's pretty well what we can write. You could say my answer is reasonable because 601,801 is close enough to our estimate when rounding to a high place value. And so you have to keep that in mind. The lower the place value you're rounding to, the less opportunity there is to be a big difference between the numbers. And of course, the larger the place value, if you get into millions and hundreds of millions, billions, you have more potential for a big difference between the numbers. So this is a reasonable answer. Yes, there's almost 100,000 difference between the estimate and the actual, but that makes sense because we're rounding to a high place value. All right, let's go take a look at 3. What do you say, huh? Yeah, let's do it. And you see number 3 is often the case in Eureka Math. They're done holding your hand with this ABC stuff, walking you through. All 3 parts of that are right in here. Let's take a look. A local store was having a 2-week back-to-school sale. They started the sale with 36,390 notebooks. During the first week of the sale, 7,424 notebooks were sold. During the second week of the sale, 8,967 notebooks were sold. How many notebooks were left at the end of the 2 weeks? Is your answer reasonable? So this question actually is a tad bit easier than that last one. Okay, we have the first week, we have the second week, and then we want to see how many notebooks are left. So we actually have, right, how many parts do we have? We have first week, second week, and then the remaining notebooks. So to draw this tape, we would need 3 parts in it. We do know the whole, we do know the total number of notebooks is 36,390. And then we know the first week, and remember we have 3 parts here, so leave room in your tape for 3 parts. We know the first week they sold 7,424. And then we'll split this. It doesn't matter if they're proportionally the right size or whatever. Just 3 parts is what we need. Second week we have 8,967. And then this is the remaining notebooks. Let's call it N for notebooks. Okay, so now what we need to do to answer this, well, if we subtract these from the total, it will give us the remainder. So our first step we learned in that first problem would be to combine these two. Instead of subtracting twice, we subtract once and add once, which is just plumb easier. Okay, so we need to find these together here. Well, let's do that, huh? Okay, so that will be 8,967 together with 7,424, which is 7 and 4 make 11. 1 and 6 and 2, 9, all right. And then 9 and 4, 13, place the 3, regroup the 1. I see a pattern here. 1 and 7 are 8, 8 and 8 are 16. Drop that comma. Okay, so this is the 16,391, the 2 of them together. So to find the remaining number of notebooks, we need to take the total number of notebooks and subtract what we have there. So let's do it over. I'm going to do it over here in the corner, so I have room for all else we need to do. So 36,390. If I subtract what was sold, is 16,391. Oh, that 1 is going to be a pain, isn't it? Oh, yes, you'll see. Because we can't take 1 from 0, so we have to regroup here. Leave 8 tens, bring 10 over to the 1's place, where there were 0 1's existing. And so 10 minus 1 is 9. 8 minus 9, we need to regroup. Yep, so go over here, leave 2 hundreds, bring over 10 tens. So now we can do 18 minus 9 is 9. And then, oh, again, we can't subtract 3 from 2 without doing that. And so we go to the thousands place, leave 5 thousands there, bring 1,000 over as 10 hundreds, with the 2 hundreds already in the hundreds place, is 12 hundreds minus 3 hundreds now, which is 9 again. I sense a pattern. All right, and now, yeah, once again, we cannot subtract 6 from 5, so we'll go to the 10,000s place, leave 2 of them there, and then bring over 10 thousands, with the 5 thousands already in the thousand place. So 15 thousands minus 6 thousands leaves 9 thousands. Drop that comma. And now we had 2 minus 1 is 1. So, okay, 19,999 notebooks left. So that's our N here. That's the answer we were looking for. That's the unknown. Now to answer, so we did answer first question, but the answer question is our answer reasonable? We know by now we want to do an estimate. Okay, so, well, how should we round these numbers? I would think to the nearest thousand, because these first 2 numbers go out to the thousands place. If we round them to nearest 10,000, they would both round to 10,000. Well, that would actually work, but we don't know that. I just kind of did it quickly. So let's go to the nearest thousand on this one. So right here, looking at 8,967, you could tell that's past the midpoint and would round up to 9,000. Looking at 7,424, yeah, you can tell that's below the midpoint and would round down to 7,000. And so together, that would be 16,000, which we'd subtract from the total. So let's round that to the nearest thousand. 36,390. What thousand does that round to? Looking at this, we have 6,000. 1,000 more is 37,000. Midpoint is 36,500. Yes, it's below, so it's going to round down. So 36,000 minus what was sold, the 16,000, leaves, you probably don't even have to really do the subtraction here. You could just say, okay, well, everything's the same except for the 3 minus 1, so it's 20,000. Now, just to mention, if you rounded each of these instead to the nearest 10,000, you would get 10,000. 10,000 is 20,000, and then you'd have 40,000 minus 20,000 is 20,000. You actually, in this case, just in this case, not always, in this case, you would actually get the same thing. So you could have safely rounded to nearest 10,000. It's just that that wouldn't work. For example, if that 7,000 number were to round down, if it was like 4,800, say, and rounded down to 0, well, that's not very useful, is it? So, it was safer to round to the nearest thousand. Well, if you look at our actual and our estimate, they are 1 away from each other. So our answer is very reasonable. So we can say my answer is reasonable because what do we get for our actual? Okay, or we can call it my exact answer of 19,999 is, and I normally don't do this, but I'm going to write it in all caps, is very close. You can put in parentheses 1 away with an exclamation point, just 1. 1 away from my estimate of 20,000. And 20,000 what? Now we can define that notebooks left unsold. So you see here in number 3, we put it all together. All right, well, look at that. Hard work pays off. Homework time is done. See you when homework time comes back round again. Bye now.